So today we'll be reviewing some geometry targets that are out of chapter 10, chapter 11, and if you stick around, there'll be some chapter 3 ones too. So let's start off with the 10s. 10.1a, 10.2a, 10.2b, these are all classifying angles. So we're all going to be looking at this picture over here. And there'll be multiple different answers to this. I can't possibly give you all of them, but I can review everything with you. So it says name an acute angle. Well, an acute angle is anything, any angle, I'll just put an angle symbol, angle less, so it's an angle less than 90 degrees. So this little symbol means angle less than 90 degrees. So, well, A is an acute angle, so I could put down A. There are other acute angles. C, of course, is acute. F and G are both acute. Oops. F and G. So it just said name one, but I just named all of those acute angles. So name a right angle. Well, this angle right here, E, would be a right angle. So E would be a right angle, and that's the only one. Now going back up there, name an obtuse angle. So here's a right angle. So that angle equals 90 degrees. This is right. This is acute. This is right. And then obtuse. Obtuse is going to be like this, something greater than 90. So it'll be an angle. Notice how it's flat on the bottom. Angle that's greater than 90 degrees. And it's going to be less than 180, but that's good for now. So an obtuse angle, well, D is going to be an obtuse angle. B would be an obtuse angle. Let's see. These ones here, these are all acute, so those are really the only two that we have. So now, name a pair of vertical angles. So vertical angles would be like angles 1 and 2. Vertical angles are opposite. So which angles are opposite one another? Well, D and B are opposite, and also A and C. A and C are opposite. So D and B, A and C, these are vertical angles. Name a pair of adjacent angles. So adjacent angles, these are vert, giving you all kinds of vocabulary. So adjacent are going to be any angles that are like 1 and 2 here. They're next to one another. They share a side and they share a vertex. So, well, A and B are certainly adjacent. B and C are adjacent. C and D, and A and D. Those are all. Now you can also talk about these two. You know, G and F are certainly adjacent. F and E are adjacent. So there's all kinds of them. And they just wanted one pair, and I gave them all to you. So name a pair of angles that are supplementary. I'm running out of room here for my little ones here. So supplementary angles equal 180 degrees, and complementary angles equal 90 degrees. Again, this little symbol here, this is the angle. It means angle. Slide that down so you can see that equal angle. So angles that are supplementary. Well, A and B, those are supplementary. They add up to be 180 degrees. So A and B. And it's going to be all of these, you know, B and C, C and D. And you're saying, well, those are all the ones that are adjacent. Well, not all of them, but all of these ones right here are. So C and D, and also D and A. D and A, those are all supplementary. But over here, those angles aren't supplementary because G and F add up to be 90 degrees, and F and E add up to be something greater than 90 but less than 180. So, you know, we're talking about a pair here. So, but a pair of angles that are complementary, F and G would be complementary. And that's really the only set that are complementary. And if you want to be real fancy about this, you can see angle F and angle G. All right. So what is the measure of angle 1 now? We're looking at this drawing down here. Well, if this one is 90 degrees and this whole thing is 180 degrees, then we can go 180 minus the 90 degrees over here and get that. Most of you just know that if this is a 90, that has to be a 90. So it's 90 degrees. What is the measure of angle 2? Well, now we can do it. So if this whole thing here is 180 degrees and we subtract the 40 degrees, which is right here, that'll equal 140 degrees. So angle 2, this has to be 140. And you can see how the 140 plus the 40 equals a straight line, which is 180. What's the measure of angle 3? Well, these angles here are vertical angles. And if this angle right here is, let's say this one here is, it's a little bit less than 90. So let's say that this is 88 degrees. This is going to be 88 degrees because the opposite angles, those vertical angles, are going to be equal when two lines intersect. So if this angle here is 40 degrees, 3 has to be 40 degrees too. Okay, and what's the measure of angle 4? Well, same thing. If 4 is 100, if 2 is 140 degrees, 4 has to be 140 degrees because down here the 40 plus the 140 has to equal 182. So this is 140 degrees. So I'm just going to do one other quick drawing here. So let's just say that this is, we'll say that this is 110. This is going to have to be 70. And then this has to be 110 because this one is opposite, and this has to be 70. But look at, here's 180 degrees, here's 180 degrees, here's 180 degrees, here's 180 degrees. Okay? 180 plus 180 is 360. There's your circle too. So all of these things are tied together. All right, let's see. We're on to 10.4 A and B, which is dealing with triangles. So classify triangle A. So when we classify, we want to classify by sides and angles. And it doesn't matter which one you do first, but I like doing the sides. So this one here and this one here, these are the same length. See the little tick mark there that shows that they're equal? Now, it may not look equal, perfectly equal, because the copy machine distorts things. But this one here is not equal. It has 2 little tick marks. So this has to be an isosceles triangle. We'll just put isosceles triangle. And then we have to look at the angles of it. Well, the sides, there's 2 sides of the same isosceles. Let's look at this. Well, these 2 angles, of course, are going to be the same. But basically, when we're looking at angles, we're looking at, is it an acute? Is it an obtuse? Or is it a right? Well, it's obviously not acute, this one here, because you've got 1 obtuse and 2 acute. So it can't be acute. It has to be obtuse because you've got 1 obtuse angle and then 2 acutes. So this is an isosceles obtuse, or you can say obtuse isosceles. Let's talk about the different types of the sides. Well, we've already said if 2 sides are the same, you've got an isosceles. If you've got that's wrong here. This is an S. Isosceles. Oh, there's my S. I dropped my S there. Isosceles. So that's if 2 sides are the same, and then you've got equilateral. That's if all 3 sides are the same, and then you've got scalene. That's if all sides are different. So I'll just put 1 side now because each side is different. All right, so let's look at classify triangle B by sides and angles. Well, let's look at 1, 1, 2, 1, 2, 3. So all 3 sides are different. That's symbolized by those little tick marks. So this one here is going to be a scalene. Oops, scalene. I think I'm going to switch pens here. Try that again, scalene. And now we have to look at the angles. Well, it's got 3 different angles, but again, one of the angles is obtuse. So this is going to be a scalene obtuse. All right, let's just draw a couple other ones here. Here's a famous triangle right here where all three sides are the same. That would be an equilateral. Equilateral. And if all the sides are the same, all the angles are the same, and you'll notice that these are all acute. So this is an equilateral acute. Most of the time we just say equilateral because it's assumed that all of the angles are 60, they're all acute. Let's do another one here. This one here, put a right angle in, 1, 1, 2, 1, 2, 3. So this one here is going to be a scalene because all the sides are different, and it's going to be a scalene right. So again, you always classify them two ways, by sides and by angles. Angles and sides. All right. Now the second target is finding the measures of angle D and E on this first one. So here's angle E and here's angle D. Well, we know that there's 180 degrees in a triangle, and we could subtract the angle that we do know, which is 120 degrees. And that gives us 60 degrees. Now, those 60 degrees have to be divided equally among these two angles because they're the same. So 60 divided by 2 would be 30 degrees. So each of these are 30. Here's a 30, and here's a 30. That makes 60, and then the 120, that's going to make 180. What's the missing angle on triangle B? Well, let's just write down the formula. Here's 180. We're going to subtract 110, and then we're going to subtract 25. Well, 180 minus 110, this would be 70 degrees, minus the 25, that's going to equal 45 degrees. So this would be 45 degrees. Let me just check my math. 45, 25, that's 0, 10, that's going to give me 70, and then 110 is 180 degrees. Okay, so just start with 180 and subtract from there. Let's move on to the second page. Should be a little faster on this page. Okay, so we've got all these different quads, and I guess I have to zoom out just a touch so you have a better view of the entire page. Can't get quite zoomed out enough. All right, so we need to classify shape D. Well, here's quadrilateral D right here. Classify that shape. Well, in other words, what is it? Well, all of these angles are different. 360 minus 60 minus 100 minus 95. Well, 300 minus 60 would be 300. Minus 100 would be 200. Minus 95, that's going to leave 105 degrees. So this is a 105 degree angle right here. And if all of the angles are different, all the sides are different, you can see it. All of these are different sides. So this can't be a rectangle. It doesn't have any right angles. It can't be a trapezoid or a parallelogram. This here is just a quadrilateral, so we're just going to call it a quad. Okay, they want us to classify quadrilateral B. What could it be? Well, we've got these sides, these parallel sides, which are congruent or identical, and then these parallel sides, which are congruent. And this one here says 51 degrees. So, in this one here, this is a parallelogram. Parallelogram. And you keep in mind that in a parallelogram, if this is a 51 degree angle, this has to be a 51 degree angle. And if this is a 51 degree angle, these two together, 181 minus 51 equals 129. This has to be 129 degrees because these two also have to equal 180 degrees. And if this is 129 degrees, then this has to be 129 degrees. This says Y, so we'll probably have a question about that. We've already done some of the work on that. So classify shape A. We'll take a look up here at shape A. Well, this line here, this shows that this is a right angle. And these two lines here are obviously parallel. So we've got one set of parallel lines here. And so this is going to be a trapezoid. And so classify it as a trapezoid. And if you want to be really fancy, it's actually a right trapezoid because it's got that right angle up there. Okay, what is the measure of angles D and C in quad A? All right, we've got to do D and C. Well, if this is a 90-degree angle here, these two lines are parallel, this line and this line. That means this also has to be a 90-degree angle, because remember, these two together will be 180. And you just think about it. Here's two parallel lines. When they're intersected like that, these angles are identical. So when they're intersected by a line that's perpendicular, these lines here will be perpendicular and form right angles as well. So this one is angle C. Let's just put angle C equals 90 degrees. All right, and then we can figure out the rest. So what is the measure of angle D, this one over here? Well, let's just put that together. We're going to say that we have 360 degrees in a quadrilateral, and we can subtract 90 for the one right degree angle. We can subtract 90 for the other 90-degree angle, and then we can subtract 128. And that's going to give us the missing angle, because it's 360 in a total. So 360 minus 90 minus 90 minus 128 up here, 52 degrees. And that makes sense, because these two, 52 plus the 128, that should be 180 degrees, which it is. Okay, what is the measure of angle Y in quad B? Well, we already kind of figured that out, that has to be 129 degrees, because this one is 51, and we already did the work right here. So this is 129 degrees. And what is X in quad 3? All right, well, we know that the 360 degrees, you know what, I'll put it right inside here. We know that all of these X's together equal 360 degrees. So 360 degrees is equal to X plus X, these two, plus 3X plus 3X. So we can just combine up our X's, 1X, 2X, then we've got 3 more, that would be 5X, plus 3 more will be 8X. So there's really 360 degrees is equal to 8 X's. Again, 3 plus 3 is 6, here's 7, here's 8. This is a one-step equation. We can divide by 8. 360 divided by 8, I think that's 45, but I'm not sure. 360 divided by 8 equals 45 degrees. So 45 degrees equals X. So that means that this angle is 45 degrees. There's just one X. This angle is 45 degrees. And then this one here is 3 times 45. So just take that times 3, and you get 135. So this is 135 degrees, and this is 135 degrees. All right, so X equals 45 degrees. We've got it here. We also have it up here too. All right, let's go on to the last page. All right, sum of the interior angles. All right, what is the sum of the interior angles of polygon A? Well, there's a formula that says you count the number of sides and you subtract 2 and you multiply it by 180. And sometimes it's written like this, 180 times n minus 2, and that will equal the sum of the interior angles. So let's just start with this one here, polygon B, which is actually question 25. So we count up the sides: 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 sides minus 2 times 180. So 9 minus 2 is 7 times 180. So 7 times 180 is 1260. So this is 1260 degrees. So the interior angles equal 1260 degrees. All of these little angles put together. What is the sum of the interior angles of polygon B? So we got that. 1260 degrees. Okay, what is the sum of the interior angles of polygon A? Well, this one's not a regular polygon. You can see that they're all different, but let's just do it. 1, 2, 3, 4, 5, 6, 7, 8. So this one, I'll just show my work. I'll do it up here. So you got 8 sides minus 2, and that's going to be times 180. So that's really 6 times 180, and that is 1080. 6 times 100 is 600. 6 times 80 is 480, so that's how I got the 1080 degrees. So this is 1080 degrees, the sum of the interior angles. Okay, what is the measure of each angle in polygon B? Well, now this one right here, because it's a regular polygon, we can take that 1260 degrees and divide it by the number of angles. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. Remember? 9 sides, so there's 9 angles. We can just divide 1260 divided by 9, and that equals 140 degrees. All right, so each one angle is 140. 140, 140, 140. I'll just label 1. Okay, what is the sum of the measure of the interior angles of a polygon with 12 sides? Wait, I can't do that. There's no picture. Sure you can. Number of sides minus 2 times 180. That's really 10 times 180, which is 1800. Still not convinced on it? Here's a triangle. How many sides are there? There's 3. 1, 2, 3. So take 3, subtract the 2, and multiply it by 180. Well, 3 minus 2 is 1 times 180, which is 180 degrees. So, I mean, it works for a triangle. I know there are ways you can take and you can divide this into triangles this way too and find out how many triangles you can make and multiply it by 180. There's nothing wrong with that. As a matter of fact, I'll even do one. Here's a pentagon. You can just choose one side and then see how many triangles you can make. I can connect a line there. I connect a line there. I have got a total of 3 triangles. So 3 times 180 equals 540. But I can also do it this way. 1, 2, 3, 4, 5. 5 minus 2 times 180, which is 3 times 180, which is 540. I think the formula is simpler. Okay, what is the formula for finding the sum of the interior angles of a convex polygon? Well, it's this. We take the number of sides, we subtract 2, we multiply that by 180, and that equals the sum of the interior angles. It's an important one. Okay. Little pause here because some of you may not be doing the rest of these. So in 2021, we've got all of these together, and so we're going to do them all together. Here are the rest of the geometry targets. So 3.6 AB, area and perimeter of rectangles. What is the area of a rectangle with a length of 12? Let's just sketch it. We've got 12 and a width of 6. Well, the area, you just multiply those two guys together. 6 times 12 equals 72, and that's centimeters squared. Okay, what is the perimeter of a square with a side of 8? Well, if this is a square And if this side is 8, that means all the sides are 8, right? So that's just going to be 4 times, sorry, there's something on my table there, 4 times 8, which equals 32. You could also do it as 8 plus 8 plus 8 plus 8. And this is just going to be 32 feet. So make sure we keep the labels on there. Sorry, I think it was a cookie crumb. Yeah, I had a cookie. Now, on to parallelograms. What is the area of this parallelogram? Well, the formula is you take the base times the height. Well, the base is 8. You multiply it times the height, which is 4. And again, here, this is 32. And it's centimeters squared, because area is always units squared. What do you do with the 7? Nothing. It's a distractor. We need the base, and we need the height. Okay, what is the area of a parallelogram that has a base of 20? Draw one here, and a height of 6. So here's 20, here's my height is 6, and it has sides that are both 8, so the sides over here are 8. Well, the sides don't matter, they're just a distractor. Just multiply 20 times the 6. 20 times the 6 equals 120 millimeters squared. Okay, what's the area of this triangle? Formula is simple. It's the base times the height, and then we're divided by 2. So it's going to be 14 times the 10. Kind of weird, right? But that's the height. So 14 times 10 divided by 2. 14 times 10 is 140. Divided by 2 is 70. 70 meters. What is the area of a triangle with a base of 12? So here's 12. And a height of 8. Well, I'm not even going to draw in the sides. I can still figure that out. We're going to take the 8 times the 12, and then we're going to divide that by 2. Well, 8 times 12 is 96. Divided by 2, this is 48. Okay, and we don't know what the measure is, so we're just going to call it 48 units squared. That's what the U2 is, unit squared. All right, 2 more. What's the area of this trapezoid? Well, here's the formula for a trapezoid. The official one says it's 1/2 the height times base 1 plus base 2. So I'll do this one that way. So you take 1/2 the height. So here's the height, and here's the base, and here's the other base. So 1/2 the height. So 1/2 of 4. And we multiply that times base 1 plus base 2. And it doesn't matter which is which. This is going to be 8 plus 6. So 1/2 of 4 times, well, 8 plus 6, go inside the parentheses, is going to be 14. Then we have to do 1/2 of 4. We'll multiply these together. 1/2 of 4, 1/2 times 4 is 2. You could put that into the calculator as 0.5 times 4 if you wanted to. Times 14. Well, 2 times 14 is 28. So this guy is 28 units squared. Again, there's no label, so it's just units squared. All right, here's another way of solving this, if you like it better. You can use this formula. You can take the base plus the base times the height and divide it by 2. It's just kind of going backwards. I like it because when I can do it on a calculator easier. So here, this is 12 plus 5. And we take that times the height, which is 4, and we divide it all by 2. So you can see how I can do it on a calculator in one small fell swoop. 12 plus 5 times 4 divided by 2 equals 34. So this is 34 centimeters squared. I'll do it the other way just so you get familiar with that. So we'll take 1/2 the height, so 1/2 of 4. We're going to multiply it by 5 plus 12. Okay, well, do the parentheses first. 1/2 of 4 times 5 plus 12 is 17. Okay, now 1/2 of 4 is 2 times 17 equals 34. There's your 34 again. All right, thanks for listening. Have a good day.